Some reason, because the IETF thing was every time that I research everything, Wi-Fi access, when this thing is massive, whether it's
these days I have to like schedule 4 hours in advance, which I mentioned. Friendly man, I'm wanting to see that. Don't train for expensive months.
Well, this particular laptop is kind of
My employer does not want to.
complicated because it does
It's national.
I'm just because
the injury is I sat in a plane.
Who wants to? Somebody somewhere in.
I've updated Visual Studio.
Okay. Hello, welcome to Trans. Hello. I don't think this mic, is this mic working? Is this mic working? Hello? Test 1, 2, 3. Yeah, the one that's on. La 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 la. 1, 2, 3. Sure. Or is this sort of like a Google mic drop presentation?
How about this one? No, it's not even.
Jabber can hear me. Okay. Another room can hear me too. Okay, great, excellent. Hello, everyone. This is the Trans Working Group meeting. If you're not here for Trans, go have some coffee. So everybody's familiar with the node well. It's still Monday, so if you've never read this, then you're too late, and you should probably let your lawyers read this. And but if you stay here, then you'll agree to it. I'm hoping we don't need the entire time slot because I think there's not that much items to talk about. The BIS document is in a pretty good shape, and the threat analysis is also in a pretty good shape. So just a quick update on it. So we have no issue no changes on the charter. The tracker has 17 open issues compared to last time we had 22, but last time we had issues open on the BIS document, and currently the BIS document has no open issues. So we're really hoping to start working group last call on it. And for that, we have Aaron giving a remote presentation. So Aaron, are you around? I'm going to press this big red button, and then I think you're going to speak.
Yes, I am. Can you hear me?
We can.
Okay, perfect. Just one thing, my video feed only shows the presentation, and so if somebody's at the mic, I can't see them, so let me know if there is somebody. Okay? Did you get that?
Sorry, I am finding your PDF, which has vanished.
Okay.
So now you should see it.
So I see a frozen video feed, so I guess I'll just go and make sure that each slide title is the one that I intend, the one I'm reading with. Okay?
Okay.
Great. So I'm Eran Asari from Google. I'm one of the authors of 6962 BIS. And rather than doing my usual laundry list of, grocery list of open issues, I decided to give an overview from 6962, between 6962 and 6962 BIS, the changes, things that haven't changed and things that have. And given that there are no open issues, there is nothing that's currently pending. So that as far as I know, that's pretty definitive. Okay, so next slide, please. The one titled Unchanged. So what's unchanged? So the Merkle tree structure itself and the way it is used have remained the same. Particularly, so nodes and leaves are hashed the same way. So nodes and leaves have a different value prependent to them when they are hashed. That remain the same. The way that inclusion and consistency proofs are used are created and used is again they're conceptually the same. In a 6962 BIS, there is a new I think one of the appendixes or one of the sections towards the end details the algorithms for checking, not just generating, but also checking and validating consistency and inclusion proofs. The concept of pre-certificates has remained, but the implementation has changed. That's in the next slide. And the SCT distribution mechanisms have also remained the same. These are embedding in certificates, TLS handshake, and staple doses per responses. Next slide, please. The one titled Removed. So what's been removed is the pre-certificate, the concept, and the pre-certificate signing certificate. So in RFC 6962, like issuers could use an intermediate certificate to sign the pre-certificate different than the one used for issuing the final certificate with the SCTs embedded in it. But because pre-certificates are no longer X509 certificates, then there is no need to have the pre-certificate signing certificate. So that's gone. For the same reason, the poison extension, the critical extension with a null value is also no longer needed because the certificates are no longer X509 certificates. We've also removed one layer of abstraction from the Merkle tree leaf data structure. There was just an extra layer that was not really necessary, so we removed it. And SCTs for X509 certificates, as opposed to pre-certificates, are no longer over the entire certificate as is. So we've simplified and unified the data structure used for signing, for basically over which the signatures in SCTs are valid for, and it's the same for X509 certificates and pre-certificates. But now that means that the SCT for the X509 certificate doesn't cover the entire certificate as is. Questions so far? Okay.
No questions from here.
Okay. So next slide, please, titled Changed Overview. Okay, so I think the biggest change, or one of the biggest changes, is pre-certificates. The pre-certificates are now CMS objects that contain the TBS certificate designated for the final certificate. Crucially, the serial number of the final certificate, the final X509 certificate, is still included and is still needed. But, and some of you may recall, the main objection to the previous format of pre-certificates was that these were actually X509 certificates, and issuers would sign this basically different certificates twice, but with the same serial number twice. And there was a strong pushback from that. So now pre-certificates are embedded like in CMS objects, and you'd still have to use the same issuer, the same intermediate certificate, CA certificate to sign the CMS object, but that is no longer an X509 certificate. As for the other big change is private DNS labels and the way to deal with them. So with a 6962, each certificate had to be logged as is, and 6962 BIS allows redacting labels from the domain name in the pre-certificate, or logging completely avoiding logging identity certificate by logging a name-constrained intermediate CA certificate with, again, a special extension indicating these are logged instead of the entity, the leaf certificate, and they are also technically constrained or fit the CA CAB forum definition of technically constrained certificates. So they sort of fulfill both requirements. The other thing is log IDs. They used to be the hash of the log's public key, and we have switched to using OIDs. The benefit is they take up much fewer bytes. So it used to be 32 bytes for each log ID. Now short OIDs you can do with like 4 bytes, but obviously more administrative work is required to make sure that these OIDs are allocated from somewhere, and that does slightly complicate the client implementation, because now there is another piece of metadata that clients need to identify logs. Next slide, please, titled Log Entries in RFC 696-2bis. So we've introduced new data structure, trans item, that is basically used everywhere. And that encapsulates all of the pieces of data that we would like to return. So if you look at the first two, the X509 entry v2 or preset entry v2, these are just entries for pre-certificates. It also contains SCTs, preset SCTs, tree heads, signed tree heads, consistency proofs, inclusion proofs, and a combination of the above. And basically, wherever we return like a binary data structure, it will be a trans item. It partly simplifies client implementation, because that's the exact thing that will be passed around, and that also future-proofs the protocol to an extent, because new data types could be added to trans item and transmitted over RFC 696-2bis compliant channels. Next slide, please, titled Log Entries, continued. So what do we have in the log? As I mentioned, the concept is pretty much the same, but the data structure in logs now is a trans item structure, only of type X509 entry v2 or preset entry v2. Only one of those, nothing else. So you can't put into log leaves anything else. And both of these structures encapsulate the data structure called timestamp certificate entry data, which is detailed in the next slide. So next slide, please, titled Log Entries Leaf Data. So both for pre-certificates and X509 certificates, we take the pre-certificate, and together with the timestamp issued by the log and the issuer key hash and extensions, is a blob of data that we will use, that will be signed in the signed certificate timestamp. So as I mentioned earlier, because the SCT, the signature in the SCT for X509 certificates is not over the entire certificate, we always attach the issuer key hash to basically to bind the issuer to the TBS certificate, right? So clients can be confident that when the log saw this pre-certificate, it was issued by a particular issuer and no other issuer. Another point is that the extensions, the SCT extensions field is now typed. So no SCT extensions are currently specified, but it will be easy to specify one, whereas in the RFC 696-2, this was basically an opaque string without any semantic meaning defined. So should we ever have to define extensions, it should be pretty straightforward. Next slide, please, titled Log Entries Original Submission. So, and that's the structure that is returned by the log together with the leaf data when a client calls get entries, and that is the original submission. In case of a preset, we have the CMS preset that was submitted together with the chain that was used to validate it. And in case of an X509 entry, we have the leaf certificate and the chain that was used to validate it. And next slide, please, titled Data Structure Related Changes. So the biggest benefit of using trans item is that we can use it everywhere where, basically we intend to use it everywhere where 696 SCTs are used, so either in the TLS extension, embedded certificate, and that allows embedding or attaching of inclusion proofs together with certificates. So rather than forcing the client to go fetch an inclusion proof, for example, a TLS server could serve the certificate, the SCT, a fresh signed tree head, and an inclusion proof chaining up to that signed tree head to the client, thus saving the client the need to do a lookup, and also helps the client preserve its privacy by not forcing the client to expose the log which certificate it's interested in. So basically, wherever an SCT list was used, a trans item list can now be used. Next slide, please. Signed certificate timestamps. So the signed certificate timestamp structure is defined as the log ID, the timestamp, the extensions, and the signature over a trans item of the timestamped entry trans item, and that timestamp entry is a trans item of type X509 entry v2 or preset entry v2 only, which is the one that I've mentioned like a couple of slides earlier. And as you can see, the log ID is part of the SCT. And that's true, I think, for the STH and all other the STH as well, because now that the log ID is not the hash of the log's public key, clients need a different way to figure out which log are these signed data structures come from, and which is why the log ID is part of the data. By the way, I do have an intention to publish the same information in the document format, with slightly more explanations and background where necessary. So you don't have to take notes. Next slide, please, titled Client API Changes. So before I go into the sort of client-facing API changes, are there any questions about changes to the data structure so far?
Nobody's getting up.
Okay. Right. So in that case, as for the, I'll go into the basically client-side, client-facing API changes. I'll note that all the HTTP methods from 6962 have changed, and they all now live under CT/v2. The old ones live under CT v1. There are changes that affected all APIs and some that are specific to a few API calls. The main thing is that rather than return JSON, we now return trans items encoded TLS encoding rather than JSON. So previously, like in 6962, a client calling add chain or get STH would get a JSON, and they would then have to assemble the TLS encoded data structure to check the signature over. Now the JSON returned will return base 64 encoded trans item, and the trans item is encoded in TLS encoding, which means client implementation, particularly for issuers, it's much simpler. Basically, client can take the result from an add chain call, from several add chain calls to several different logs, put them in one structure, and embed that in the certificate, or serve that like in the TLS handshake. We've introduced error codes, both fixed strings and human-readable ones. And these are defined for all methods, so each method specifies its own error codes. And additionally, we have explicitly designated HTTP error codes 500 and 503 as transient errors. So when the log sends that back to a client, the client is expected to retry. Another issue is dealing with SKU and distributed log implementations. So basically, the problem there was that the log can have several front ends. Some of them know about a newer STH than others, simply because it takes time to distribute the same data to all front ends and to switch them all to serve new data. So it could be that a client would call get STH, learn about a new STH, then we'll call get entries or request an inclusion proof up to that STH, and that the second request will reach a front end that doesn't know about the new STH yet. In that case, the front end can't answer the client, and there is no guarantee that the client, when it tries calling get STH again, for example, will reach that front end and not the newer one. So the way we've addressed it is by allowing a particular log front end receiving a request for an inclusion or consistency proof that it that is up to a tree that it is not aware of, it can now reply with a proof chaining to the STH it is aware of and include the STH itself in the reply. So that somehow decreases the delta between tree sizes that the client has to know about or validate. So when a client receives an answer from such a front end that includes an older STH, it can hold on to the slightly older STH and then just retry getting a consistency proof between the slightly older STH and the newest STH it knows of. Next slide, please, titled the method-specific client API changes. So the returned value changes for all of these methods, chain, add, pre-chain, get STH, and get STH and consistency proof, and get proof by hash, have all changed, as I mentioned, to return the binary. The STs and STHs are returned in the binary representation, base64 encoded, rather than JSON, and the same goes for the inclusion and consistency proofs. So if you remember in the trans item, we've defined basically data structures for providing inclusion and consistency proofs. These will also be binary encoded. Next slide, please. One titled Client API Changes Continued. So for add pre-chain, there is a different pre-certificate encoding using CMS that I've mentioned. Get entries, we've renamed so there were two values returned from get entries. And the second one was one was the leaf data, and the second one was called extra data, which was actually the original submission. So that was now renamed to log entry. And we also returned the SCT for that particular entry, which means mirroring logs is now trivial, because mirroring software can just call get entries on all entries and have exactly the same data as the original log. Get STH consistency now optionally returns, this is for getting a consistency proof between two STHs, and it optionally returns an STH if the second tree size, the newer one specified by client, is unknown by the particular log front end receiving this request. Get proof by hash and get entries. These methods too can also return base64 encoded STH if the client asks for a tree size that they don't know of yet. So they can return the entries or a proof up to the point that front end knows about, plus the STH for that up to that point. There is a new method called get all by hash, which gets as a parameter the hash of the leaf the client is interested in, and returns a fresh STH, a consistency proof. The client can also specify the tree size it knows about. The client will then get a fresher STH, a consistency proof between the STH it knows about and the fresh STH provided, and an inclusion proof up to that tree size, up to that STH the tree size, the one returned by this method. Next slide, please, titled Client API Changes Continued. So we've renamed one method, get roots was renamed to get anchors, and get entry and proof was removed. That's a method that was basically in 6.9.6.2 for debugging purposes, and while implementing, in 6.9.6.2 was there for debugging purposes. We didn't find a use for it. I think that even logs that implemented it, nobody really used that, so we've just removed that. Questions about the client API changes? No.
No.
Okay. So next slide, please, which is also my final slide about backwards compatibility. It's very simple. There is very little backwards compatibility. These are separate protocols. So logs, from the perspective of logs, they can either conform to 6.9.6.2 or 6.9.6.2 bis. They can't conform to both because the data structures are different. The way, so basically different things are hashed and the leaves are different. So it is not possible to create and run a log that will produce SCTs that are compliant with V1 and V2. However, V1 and V2 SCTs, basically V1 and V2 SCTs are independent creatures. They are delivered using different extensions. So there is a new X509 extension for V2SCTs, a new TLS extension for V2 clients, and a separate extension, a separate OCSP extension. So that means that V1 and V2SCTs can coexist, and TLS clients can support both simultaneously. The only issue is with embedded SCTs, right? We have required V2 clients to remove V1 SCTs from the TBS certificate portion of the certificate before they validate V2 SCTs over it. The problem is that V1 clients are obviously not aware of V2 SCTs, and obviously for an issuer, it's not possible to send the pre-certificate both to V1 and V2 logs, because if V2 clients were not aware of V1 SCTs, then V2 clients would require V1 SCTs to be present in the pre-certificate, and V1 clients would require V2 SCTs to be present in the pre-certificate for it to be valid. So because that's impossible, V2 clients will simply remove V1 SCTs from the TBS certificate and only then validate the SCTs. So the way an issuer can create an X509 certificate with embedded SCTs, both V1 and V2 SCTs, is by first sending the pre-certificate to V2 logs, collecting all the V2 SCTs, embedding those in the TBS certificate, send that producing a V1 pre-certificate, like a 6962 pre-certificate from that TBS certificate that contains the V2 SCTs, send that to CT logs, get V1 SCTs, embed them, and then sign this TBS certificate to produce the final X509 certificate. So that when V1 clients check V1 SCTs, they check it over the entire TBS certificate, including the V2 SCTs, as opaque extensions. And when V2 clients check the signature over the pre-certificate, they remove both V2 SCTs and V1 SCTs, and they are left with the same TBS certificate that was sent to the V2 logs that issue these pre-certificates. So to conclude, it's possible to basically V1 and V2 SCTs can coexist, and it's also possible to create X509 certificates that have both V1 and V2 SCTs in them, and will be valid both with V1 and V2 clients. That's it. That's the overview of the changes. As I said, I intend to post to the list a document saying basically the same thing I've said here, with slightly more explanations.
Okay, thanks, Aaron. Are there any questions on this document or comments? So the plan is to move this to worker group last call. I'll talk to Melinda about that, but like in the next day or so, we'll probably announce the working group last call for this document. So the other presentation we have is Daniel. He will talk about the current setup of the gossip document. They submitted a new document recently, new version, and he will talk about that.
Okay, so this is the gossip draft is something that Linus Nordberg and Tom Ritter and I have been working on. Next slide, please. So just to recap here is that I'm going to talk a bit about what's changed, but just to be clear, the point of gossip is to be able to detect log misbehavior, and so we want to make sure that the logs aren't doing things like presenting split view attacks, split views to different parts of the network, or rolling things back in time. So we want to make sure that the logs are actually publishing things that they have contractually agreed to do. So we've made a few changes in the draft. One of the hardest part of dealing with gossip in the CT scenario is that you potentially have a lot of privacy concerns, because if you're gossiping about information about what things you've seen, you're effectively potentially gossiping about like your browsing history, for example. So, it's become fairly complicated, and the rationale for the complication is to try to minimize the amount of privacy leakage that's there. So the things that have changed, so just a quick recap on gossip if folks don't remember how that works. There's 3 different methods by which information can be gossiped. One of them is called SCT feedback, where the HTTPS client sends the SCTs that it's seen for a given host back to the host on subsequent connections. And it does that, it's basically, we're not leaking any information to any outside party. The host that you're visiting might know that you've been there before, but you're not going to actually be, you're not telling arbitrary other people that you've been to this one host. So that's SCT feedback. There's STH pollination, which is where when you talk to a given host, you show it the most recent STHs you've seen from all the logs that you know about, or from some of the logs that you know about. And it also gives you some recent STHs from those logs. And that way STHs get pollinated around so that a malicious log can't serve a victim an STH and hope that nobody else ever sees a copy of that STH. Those STHs will be pollinated from browser to client to browser, browser to server to browser to server to browser to server all around. And then the third one is a trusted auditor, which is that you have a pre-established relationship with an auditor and you can show them the artifacts, the CT artifacts that you've seen, and they can use them to keep tabs on the logs. So things that have changed in the new draft, we've been clearer for SCT feedback about who you should send it back to. We had some fuzzy language in there before, and we're now much clearer that it's actually the exact same host name. So if I get a cert for example.com, I shouldn't send it back to www.example.com. I should just send it back if I visit example.com a second time. And vice versa, if I get a cert for www, I shouldn't give it to example. There was some open questions about locally added logs and chains. Locally added in this case is, I think, a euphemism for the man in the middle configured by your anti-malware or your business surveillance unit. And so one of the concerns is that many of these man in the middle boxes that are set up with a phony CA will also have a phony, may have a phony log. But if they have a phony CA, the CA might be customized to you. And if you are doing SCT feedback with certs that you got from this phony CA, you might be identifying yourself because of the certificate chain. In SCT feedback, you give back the entire chain. And there's a concern that if I have a man in the middle box that I'm connecting through, and the certs in that chain are specific to my man in the middle box, they might identify me. And so if I'm submitting those back to the server that I'm connecting to, say I move off of the man in the middle network and onto another one, then maybe I'm identifying myself to the server in ways that I shouldn't be. Well, what we decided is, because you're only submitting SCT feedback for cert chains that actually have an SCT, that is where your certs have actually been, where those certs have already been logged, that that information is already logged and you should go ahead and publish it. So you should send it back to the server, that there isn't a privacy concern. We wanted to also minimize the number of code paths available when you're thinking about what do you send back. So we're going to be sending back the entire chain, whether you have a locally added CA, whether it leads to a locally added CA or not. If you have a locally added log, as opposed to a locally added CA, that is, you've configured your browser to use some custom log that isn't a standard log, then we think you probably should not send that back via SCT feedback. We've described this auditor of last resort role, which is something that would be built into the browser, into the HTTPS client itself. An auditor of last resort is basically, so the two things you could be gossiping about are SCTs and signed tree heads. Of the two, SCTs are significantly more privacy sensitive, right? Because they tell something about which hosts you have talked to. STHs are just the latest STHs for a given log that you use. So the auditor of last resort is if you can't even get a consistency proof from one signed tree head to another because a network attacker might be blocking you, say, from fetching those consistency proofs, then the auditor of last resort is a place that you could ship your STHs to, should you need to. And the HTTP client, the HTTPS client would have that built in as an auditor of last resort. And we've defined how you send data to a trusted auditor so that if multiple people want to set up trusted auditors, we'd like to have a standard way to do that so that you could say, hey, I'm not going to be doing this kinds of feedback thing, but I do have this auditor relationship. So we wanted a clear format for that. It's a JSON format. It's not super complicated, but we'd be great if somebody wanted to take a look at it and say whether they think it's implementable or not. Next slide. If people have questions, they should ask them too. Because the privacy is a big part of this, a big chunk of the new text is trying to describe the different privacy concerns that we've been wrestling with. Turns out it's really hard to gossip stuff without leaking information about what you've been doing. So the fact that we have these three methods, we added some text to explain why we actually think we need all of them. It would be much better if we just had one method. It's not clear that we have a good way to do there's different trade-offs for each of them, and so it's useful to have all three of them working in concert. The other thing is when you're doing this when you're doing SCT feedback or STH pollination, you have to decide which, if you have a pool of things to send back, you have to decide which ones to send back and when. And so we've documented some concrete algorithms that we want to encourage clients to use when they're doing these particular things. Otherwise, it turns out there's a whole bunch of different sort of fiddly knobs you could set about, do you want to send them all back all the time? Well, no, you don't. So when do you? And if you have multiple ones, how do you choose which one? And how many times do you need to send it back before you're convinced that it's gotten upstream? Can you let go of stuff? So we have concrete algorithms proposed for that. And removed everything about monitors. It's just, we're dealing with auditors and HTTPS clients and the web servers only. So it's nice that we don't have to deal with the monitors here. The entire goal here is how the gossip framework works to get information out. And the monitor's job is to actually just go through a given log that has been properly audited and make sure that that a given host isn't being represented multiple times there. So monitors are not relevant for gossip, so we managed to remove all of that. So a little bit of simplification at least. So next slide, please. So a couple of open questions. One question, so for SCT feedback and for STH pollination, when I connect, when the HTTPS client connects to the web server, and in that connection, it sends back the feedback or the pollination. So one question is, if I send that via HTTPS, is it acceptable for that server to say, actually, HTTP 302 response, send the feedback, send the pollination to somewhere else? And there are trade-offs. If you don't allow redirection, then it will be harder for some people to deploy it. Some servers won't deploy it. They won't run a service locally that handles it. If you do allow redirection, then we're basically enabling another major surveillance centralization endpoint, right? Which is if everybody decides, oh yeah, we're not handling our SCT feedback or STH pollination, you can just send it over here to example.org, well then whoever operates, if there's one canonical place that everybody does, and all you have to do is set up this 3-line Apache redirection set, then pretty much everybody is going to have their browsers reporting all their activity back to example.org. So there's trade-offs here about deployability versus sort of centralized surveillance. I would much rather say that, fine, if you want to deal with centralized surveillance, don't do an HTTP 302 redirect, but instead accept the stuff and send it there yourself. That actually removes the privacy implications for the clients. But there is an open question: do we want to support delegation or not? We're leaning towards not. We're leaning towards saying that an HTTPS client that receives an HTTP 302 redirect should not redirect on the submission of SCT feedback or STH pollination. So. There's yeah, Stephen?
Stephen Farrell. So just, if I follow a 302 or whatever, what am I going to give to the
you're going to give them
that I wouldn't be just about to have given to the original site?
You're going to give them, you are yourself going to connect to this third party and say, hey, here's a website that I've been to.
But the site I've just been to, the guy I sent a HTTP request to, who gave me the 302, he could have just done the equivalent anyway, right? What's
he can give
different,
you,
really?
He can give you so if I go to, you're posting, right? You're posting data that says, here's some certificates that I've seen of you.
Yeah.
If the website says to you, when you're just visiting the website, don't go to me, go over to him, well, that's fine. You're not necessarily going to post the information. You're not gonna turn around and give the centralized authority the information that you were visiting that website. You might if your refer policy is loose.
I'm still not saying, so let me see if I get it right. So the context is I'm going to post some data to example.com.
And what are you going to post?
So I'm
in SCT feedback and STH pollination, the things you're going to post are the list of certificates that you've seen with the certificate chain with the SCTs that you've seen for that host.
right. Okay, so I'm connecting to example.com and I'm going to give him this stuff.
Right. I'm going to go to example.com and say, hey, I've been to example.com. Here's what I saw from you last time.
So he has all this stuff now. So he could send it to the centralized host.
That's right.
Yeah. So the only difference with the redirect is he just gets me to do it for him.
Right. And the privacy implication there is that the centralized host now knows which clients have been to example.com instead of knowing that example.com is.
But example.com could have told him all that stuff as well, right?
Example.com can tell him directly.
Yeah.
Yeah. But the question is, if the client wants to be privacy preserving, so the client.
I'm not seeing a huge difference, to be honest.
So the client could have additional, like, for example, if the client has cookies for example.com.
Sure.
Those cookies, so there's example.com and then there's the centralized thing. The client could have cookies for both of them. So if the client, remember that there are multiple web servers out there, and we're positing sort of one canonical centralized provider that everyone's just going to do HTTP delegation to.
Right.
In that scenario, if I have any sort of established state with that centralized provider, then they can learn my entire browsing history and habits.
Okay, so
if my connection is between A, B, and C individually, then yes, A, B, and C individually can say, hey, I got this cert and it came from somebody.
Okay, so I do see that there's a difference in that if I keep connecting to the collector and sending him posts from lots of different example.com and example.net and so on, he gets a bit more tracking. But
he learns the distribution of sites visited by any of the individuals that contact him.
Right. But all of the example.com and example.net they have all this information that they could all just give to the collector anyway. Right.
But they don't actually have the correlations. They don't know that you're the same person in each of the three. Whereas when you're submitting,
but if they all tell the centralized bad guy, then he gets to know the same stuff.
But the centralized bad guy doesn't know. So that maybe Ben can explain better.
Ben Kadek. So example.com doesn't know who you are in central collector's database.
Sure. I'm just seems the same.
It's
very similar.
But it is not the same, because if you have a relationship with example.com and you send it, I've been to A, B, and C, and A, B, and C turn around and say, hey, somebody's been to us, then the collector can't tell that those are three distinct, whether those are three distinct individuals or one. And the linkability between sessions, right? If I say, okay, who here has browsed Google, the answer will be everyone. But if I say, if we pick 4 websites that are distinct, you can have an individualized profile based on those connections for high dimensionality space. So anyway, that's an open question. We've said in the draft that you should only be gossiping recent STHs, and that's to prevent a fingerprinting attack where I pull an old STH and I give you an old STH during the STH pollination, and then as you browse around the web, you hand that old STH back to the browsers, the web servers that you visit, and someone can look for that old STH as something that hops around between servers and see where it came from. So it's a way to try to find a user. So instead we say you should only be gossiping STHs that are fresh, We say 14 days at 1 STH per hour, which is the limit. That's about 360 STHs.
Ben Kadek, well, unless they cheat about how many STHs they issue.
If they cheat, then that's detectable, right? So the whole
Right.
point of this is to detect misbehaving logs. And so one of the rules of the misbehaving log is like certificates must be issued within the MMD. They must only issue STHs at a certain, no more frequently than a certain frequency. So they have a set of rules that they have to follow. If the STHs are all published and visible, then you can detect that a log has failed to meet one of the requirements that it committed to doing initially. And the goal of this is to detect misbehaving logs. And then lastly, there was some concern about when you have a name redacted cert and you're doing SCT feedback, should you provide the redacted cert, even though, so you're visiting what you think is the same host a second time, should you provide the redacted cert back to that host if it may have changed? And I believe we settled on the side of yes, you should go ahead and provide that back, unless the client has some specific reason to think otherwise. But I think the current conclusion is that we're going to go ahead and encourage that to be sent back. So that's ticket 145, I think, or 146 if people want to follow up on that. So I think that's it. Yeah, we're hoping to get this into last call by Berlin. I'd like to know who here has skimmed the draft. Who here has read the draft? All right. Okay. So no one's in the middle. It's just it's nothing or actually read it. So anyway, this is where we stand. If folks have more questions, I'm happy to answer them. I really do encourage people to read the draft. The privacy considerations are daunting, but we need to think about them. And if we don't monitor the logs, then we just created another layer of potential abuse. So, all right.
Thanks. So no more questions on this. Nothing remote either. So the other document we're working on is the threat analysis. There was some discussion about the dual CA compromise attack. So Steve committed to updating those two sections, section 3.3 and 3.4 of the threat document in the next week or so. So once we receive that and see what the discussion says, we'll probably also bring that document into working group last call. So the other two topics that we have sort of let wait for a bit while we were working on the core documents is the DNSSEC one and the binaries one. I know that Linus Nordberg has done some work on the DNSSEC on implementing it, but I don't know exactly what the status is. I'm not sure if you know more, Daniel.
So I believe the current status is that there's just sort of an experimental attempt to log the root zone, and the pieces are being put in place. There is a log that accepts, I think, some of this data, but there's a bunch of work still being done to like try to avoid it being spammable, and so it's not like there's nothing useful yet to report back. But if people are interested, there is a DNSSEC transparency mailing list that people can join if they're interested to talk about it.
Okay, so then if anybody has any other business, then now is the time. Okay, so I guess that's our fairly short meeting for this time. So hopefully next time we'll have lots of documents in working group last call or better. Okay, thanks.
Well, that's also hard. If you require change to inside this. Which means that you're probably. It's relatively. Right, you're already talking to the server that you're not. You're already talking to the server that you shouldn't be talking to. Or you're already wanting to know. I was. The local government forces like that.